Imagine you have encountered a problem in your code where you need to constrain the types within a templated class to meet certain criteria. In this case, you have a class containing a tuple, and you want to ensure that all types within the tuples satisfy the STD, movable concept. This can be a tricky problem to tackle, especially when dealing with templated types within the tuple. How can you apply constraints to ensure that all types meet the required criteria? Now, let's delve into the solution provided. The most straightforward approach is to utilize the STD, movable concept. By specifying STD, movable for the types in the template parameter pack, you can ensure that all types contained within the class template meet the movability requirement. This helps guarantee that the types can be moved successfully within the tuple, ensuring the overall functionality and safety of the code. Building upon the initial solution, if the types within the template are also templates themselves, you can perform specialized checks to verify their movability. By creating a concept that checks if a template class becomes movable when instantiated with specific types, such as int, and std, string, you can further enforce the movability constraint. This additional step allows for a more comprehensive validation of the types within the template, ensuring that the code remains robust and dependable. In summary, by incorporating concepts like STD, movable, and specialized checks for template classes, you can effectively constrain the types within a templated class to meet specific criteria, such as movability. This approach enhances the reliability and maintainability of your code, ensuring that it functions correctly and efficiently. Thanks for watching, and remember to subscribe, like, and comment with your thoughts on this solution.